Let's see this question of IIT-JEE 1991. A block A of mass 2m placed on another block B of mass 4m, which in turn is placed on a fixed table. The two blocks have a same length 4d and they are placed as shown in figure. The coefficient of friction both static and kinetic between the block B and table is mu. There is no friction between the both blocks. Small object of mass m moving horizontally along a line passing through the center of mass of the block B and perpendicular to its face with a velocity v collides elastically with the block B at a height d above the table. So part A, what is the minimum value of v, call it v naught, required to make the block A topple, and B, if v is equal to 0, find the distance from point P and the figure at which the mass m falls on the table after collision. Ignore the role of friction during collision. The last line, ignoring of friction during the collision, saves lot of effort, because if we don't have to ignore the friction during the collision, our life would be very difficult. So thank God we don't have to consider friction during collision. So let's go ahead and understand the condition of toppling. So this is the situation before collision. There is no friction between A and B, and there is a friction between B and the surface. So the A will immediately after striking A will be at rest, because there is no force in the horizontal direction, and the time of collision is very small, and during that time we have to ignore the effect of friction. So immediately after collision, A and B will get some velocity, because B gets momentum in the right direction, impulse in the right direction. So B will start moving towards right, and A will stay at rest at its position. So when B will reach to the half of this length is 4d, and when B will reach up to here, then mg at this position, mg and normal will be just at this position, and when mg and normal on the same line, that till that moment A will be in equilibrium, and when normal reaction line of action passes outside the base, that moment A will topple, and about that we'll look in detail later. But first of all, we want to find the velocities of the colliding ball and B just after collision. So this is just before collision, and this is the picture of just after collision. So suppose the B moves towards right just after collision with velocity v1, and the colliding body moves towards left with velocity v2 just after collision. And now the collision is perfectly elastic, so velocity of separation just after collision is v1 plus v2 is equal to E times of the velocity approach. E is 1 because collision is elastic, so and velocity approach is v minus 0, that is 0. So v1 plus v2 velocity of separation is equal to velocity approach, which is v. This is my first equation. And conservation of momentum, because till collision we have to neglect the effect of force, so momentum just before collision is mv, and momentum just after collision is 4mv1 minus mv2. So let me divide m in this equation to both sides, so we'll get 4v1 minus v2 is equal to v. So this is second equation. Adding these two equations, we will get 5v1 is equal to 2v. So v1 we will get 2v by 5, and putting this v1 into equation 1, we will get v2 is equal to 3v by 5. So we got the velocity of the block B and the colliding body just after collision. Now coming to the condition of toppling. So this is the picture of A and B just after collision, because there is no friction between A and B, so there is no horizontal force on A, so A will remain at rest, and the B has got velocity v1. So now A is at rest and B is moving towards right. If we talk about A, this is A, its weight is 2 mg, obviously acting towards center of mass, and the normal reaction will be here, and normal reaction, till normal reaction is at the same line of the mg, it will not topple. Now as this B is moving forward, so the available base for the normal reaction is decreasing. Now the normal reaction can only act here, and once B, the lower mass, reaches exactly at this point just below the center mass of A, at this moment the normal reaction and mg are still on the same vertical line, but just after that moment when B crosses the middle point, just after the B crosses the middle point, the normal reaction can only be within the base. So mg will be here, and just after normal reaction moves here, so there is a little gap between normal reaction and mg, so that will constitute a force couple and it will topple it like that. So when A will topple when B has traveled a distance 2d, and for that to happen we have to find the minimum value of V, and that minimum value we have to call V0. So I think that is clear. So A will topple when the B will move a distance 2d. So on B there is a friction acting, as now there is relative motion between B and ground, so there is a relative motion has started, so a kinetic friction between B and ground is working, and that kinetic friction between B and the ground would be mu into normal reaction. Normal reaction between B and ground is a 6 mg, so mu into 6 mg. So acceleration of block B is the net force, which is Fk, which is a 6 mu mg divided by total mass of B is 4m, so that would be 3 by 2 mu g. And this is actually retardation because this acceleration is opposite to velocity of B. So speed of B will decrease, but B has to make a topple and the speed of B is decreasing, so there will come a moment then B will come to a stop, and but the B doesn't have to come to a stop before toppling A, and that job has to done by the minimum value of V, and V1 is a function of V. So if B happens to come to stop just when A is a turn, so its job is done, and that too with a minimum value of the V. So by that time the B has to travel a distance 2d, and it is moving with a uniform acceleration, so we can apply third equation of motion. V square is equal to u square plus 2as. The final velocity when it stops is obviously 0. Initial velocity v1, acceleration opposite to displacement, so I will write minus a, and displacement is 2d, and put the value. So v1 square is equal to 2 into 3 mu g by 2, and this is 2d. So this 2 and 2 will get cancelled, and v1 we calculated 2v by 5, so put it here to v by 5, and that v1 that v we have for the minimum value of v to require to make a topple is v0, so I will write v1 is equal to 2v0 by 5 and the whole square, and this is a 6 mu g d. So v0 will be if we take a square root, so that will be 5 by 2 square root of 6 mu g d, and that is the answer to part A. Now part B. If V is equal to 2v0, find the distance from the point P in the figure at which the mass m falls on the table after collision. So this point was P, and just after collision we calculated the velocity of the colliding body v2, and v2 we calculated to be 3v by 5. So v2 we calculated 3v by 5, and v is twice v0, so that will be 6 v0 by 5, and this v0 we just calculated 5 by 2 square root of 6 mu g d. So v2 is equal to 3 into square root of 6 mu g t. And beyond this movement, the motion is a projectile motion. This is moving under a uniform acceleration due to gravity, and the height at which it collided, that height was at a distance d from this surface. So this is a horizontal projection, so time of flight from here to here, and for the horizontal projection we can directly apply the square root of 2h by g, and h is d, so the time of flight is 2 d by g, and then a horizontal component of velocity is constant, so if it goes at a distance x from here, so we can use x is equal to v2 into t. v2 is 3 into square root of 6 mu gd, and this is t is equal to 2d by g, and this will become 3 square root of 12 mu d square, and this will become 6d into root 3 mu, and that is our final answer. Thank you.